Hello and welcome to our lesson on adding and subtracting rational expressions without common denominators. So we've been building up for a few topics to get to this point. We know that to add and subtract fractions we have to have common denominators. In the previous topic we looked at how to find the least common denominator when we're dealing with rational expressions. And remember, the same rules that apply to normal fractions are going to apply to rational expressions. So before we look at putting together the adding and subtracting, the finding the common denominator with rational expressions, let's just review how we get common denominators for normal fractions when we don't put the rational expressions in there. We know that, for example, if we wanted to add these two fractions, if I wanted to add a half and 2/3, that I would have to start by finding that least common denominator. Now really any common denominator will do, but the least common denominator is going to be the goal, so that we have less reducing to do. Okay, so once we figure it out, in this case, and this is the same one we looked at in the previous topic, we know that the least common denominator for these two fractions is going to be, for 2 and 3, is going to be the same as the least common multiple, which is going to be 6. So if we know that our LCD is 6, how do we go about using that to actually add these two fractions? So what we need to do is get both of the fractions to have that common denominator. And what we're going to do is multiply these fractions to make that happen. Now when we multiply, the only number we're allowed to multiply by in order to not change the value of the fraction is 1. If I multiply by 1, I'm not going to change the value of the fraction. So when we multiply, for example, 2. If I need the 2 to be a 6, which is my common denominator, my least common denominator, I'm going to have to multiply by 3. Now when I multiply by 3, I'm actually multiplying by 3 over 3, so that the top and the bottom get multiplied, and so that the 3 over 3 again is 1, and when I multiply by 1, I don't change the value of the fraction. So we're going to multiply the first fraction by 3 over 3, because 2 times 3 is going to give us 6. And when we multiply 2/3, we're going to multiply by 2 over 2. Again, that's going to give us the 6 that we need. And multiplying by 2 over 2 is multiplying by 1, and that doesn't change the value of the fraction. So we find the LCD, and then we multiply each of the fractions, top and the bottom, to make them match that common denominator. So here, that's going to give us, on the first fraction, 3 over 1, or 3 times 1, I mean, is going to be 3 on the top, and then 2 times 3 on the bottom is going to give us the 6. And then we're going to be adding to that our new fraction here, which is going to be 2 times 2, which is 4, over 3 times 2 again, which is going to be 6. Okay, so we multiply, and now that we have common denominators, we can keep our common denominator, and we can add our numerators. So the 3 plus the 4 gets us 7, and 6 is our answer. Of course, we would reduce if necessary, but since 7 over 6 doesn't reduce, then that would be it. Okay, so we need to figure out what our common denominator is, multiply our fractions to make them match that common denominator, and then we can add or subtract just like we did in the 2 topics ago. Okay, so when we apply this process to rational expressions, we want to first make sure that all of our denominators are factored. So we're going to factor all of our denominators, if that's a necessary step, right, to make sure that we can identify correctly what our least common denominator is going to be, and then we're going to multiply. And what we're going to multiply by is, again, the top and the bottom of each fraction will get multiplied. We're going to be multiplying each fraction by the part of the LCD that the denominator is missing. What does the common denominator have that the bottom of my fraction doesn't? That's what we're going to multiply by. And then that's going to allow us to combine our numerators, keep our common denominators, and that'll leave us just one fraction that we can simplify by factoring and or reducing. Okay, so let's look at an example here. So if we wanted to add 2 over 3x to the 5th and 5 over 6x, I can't add as is. I need to establish what my common denominator is going to be. So in this case, my least common denominator is going to have to be the smallest number that 3 and 6 go into, which is 6. And then we take any variables and their largest exponents, so x to the 5th. So I need both of those denominators to be 6x to the 5th. So let's start with the first fraction. What am I going to have to multiply to make 3x to the 5th 6x to the 5th? All I have to do is multiply the 3 by the 2 to make it a 6. So multiplying by 2, that's going to give me my 6x to the 5th. Okay? Now sorry, getting carried away with my dots everywhere. The second fraction, I have 6x, I need it to be 6x to the 5th. So it's got the 6 part, don't have to mess with that, but it's only got an x to the 1st, and I need it to be x to the 5th. So it's got 1x, but it needs 5 of them, so it's missing 4. If it's missing 4 x's, I have to multiply by x to the 4th power. And then 6x to the 1st times x to the 4th is going to get me 6x to the 5th. Okay? So now I can multiply. This is going to give me 4 over 6x to the 5th, plus this is going to give me 5x to the 4th over 6x to the 5th. And now we're in good shape. We've got our common denominators. So now we can keep our common denominator and then try to combine the like terms from the numerators. Now, I can't actually combine a 4 or a 5x to the 4th, so I'm going to bring both of those terms over, and I'm going to bring them over in descending order, and then see if this is a fraction that I can simplify. Well, the 3 terms don't have anything in common. Nothing goes into 5, 6, and 4 other than 1. All of the terms don't have any x's, and there's nothing I can do to factor, which means this is it. This is my answer. Okay, nothing else we can do with that. Alright, let's try another one that is a similar type. So we need a common denominator for these two denominators. So the smallest number that 2 and 5 go into is going to be 10. And then I've got x's and y's, so I'm going to have to put an x to the 3rd and a y in my common denominator. So what am I going to have to multiply my first fraction by? Well, the first thing is to get from 2 to 10, I've got to multiply by 5. And then this denominator has a y, so does this, but my common denominator has an x to the 3rd, and this denominator doesn't. So I'm also going to have to multiply by an x to the 3rd. And that is going to get me my 10x cubed y. Again, just getting carried away with my dots. So sorry. Okay, second fraction. Well, to get from 5 to the 10 that I need, I'm going to have to multiply by 2, and I've got an x cubed, but I'm missing a y, so I'm going to have to multiply by a 2 and a y to make my 10x cubed y. And now I should be in good shape. So that's going to get me 35, x to the 3 and 1 makes 4, over my common denominator, which was 10x cubed y, minus, this is going to be an 8y squared over my common denominator, which was 10x cubed y. And now we can actually put these fractions together. So we're going to keep our common denominator, 10x cubed y, and then I'm going to try to subtract my terms from the numerators. Remember, if you want, this is a minus that belongs with the 8y squared, but these are not like terms, so I can't actually combine them. So I'm going to bring over 35x to the 4th and my negative 8y squared and see if I can simplify this fraction. Well, nothing goes into 10, 8, and 35 other than 1. Only 2 of the terms have x's, only 2 of the terms have y's, so I can't reduce any x's or y's, and there's nothing I can do to factor here, so again that means this is our answer. Okay? Hopefully this is not so bad so far. Moving right along. Alright, so let's look at this guy. Remember, when we're finding a common denominator, our binomials are going to be considered separately from our single terms. So the least common denominator for these two fractions is going to have that single term, which is the x, and the binomial, which is the x plus 1. So the first fraction has the single term. It has the x, but it doesn't have the binomial, which means I'm going to have to multiply by x plus 1 on the top and the bottom. And then the second fraction has the binomial, but not the single term, not the x. So I'm going to have to multiply by an x over x. And you can see here again, now my denominators look the same. They both have an x and an x plus 1. Okay, so let's see. We got to be a little more careful here when we're multiplying by a binomial. Make sure to distribute. That's going to give us 5x plus 5, 5x plus 5 over our common denominator, which is an x and an x plus 1, plus we have a 3x times an x, which is going to be a 3x squared over our common denominator, which is the x and the x plus 1. Now in the numerator I decided to distribute I decided to distribute the 5 to the x and the plus 1 because I'm going to try to combine the like terms from the numerator. In the bottom I chose not to distribute because ultimately we're going to be trying to get to one fraction that we want to factor and reduce if that's possible. So I have to be able to combine like terms from the numerators. I want to distribute there, but I want to leave the bottom in factored form because eventually I'm going to need to simplify. Okay, so from here we've got a common denominator. We're going to keep it. So let's bring over our x and x plus 1 and then try to combine like terms from the numerators. Well, none of those terms are like terms, so I'm going to bring them all over in order. 3x squared and then 5x and then 5. And this fraction doesn't reduce, but we would try to factor the top. So 3 times 5 is going to be 15. The only factors of 15 though are going to be 1 and 15, which won't give us a 5, or 3 and 5, which won't give us a 5. So this isn't going to factor, which means this is not going to simplify, and this is our answer. Okay, so a lot of times we won't have to worry about the simplifying part of it. Alright, so here's one that's just like the last one. If you're feeling comfortable so far, this would be a good opportunity for you to pause the video and give it a try. Otherwise, let's see, our common denominator, again, is going to have to include the single term x and the binomial x minus 4. So the first fraction we're going to multiply by the binomial that it's missing, and the second fraction by the single term, the x that is missing. That's going to give us a 2x minus 8, 2x minus 8 over our common denominator, x and x minus 4, plus, it's going to give us a 1 times x, which is x, over our common denominator, x and x minus 4. Okay, now we can put these together. So we're going to keep our common denominator, x and x minus 4, and then try to combine like terms from our numerators. So I can actually put together the 2x here and the 1x here. That's going to bring over 3x, and then the minus 8. And I can't factor 3x minus 8. And I have terms with nothing in common, which again means this is going to be my answer. Okay, not so bad, hopefully, so far. Getting a common denominator, not terrible. Now, we've got one more here where we don't have to worry about any factoring, but then that's going to change. Okay, we're going to get there. But let's try one more where we don't have to factor. So our common denominator here is going to have to include one of each of these binomials, an x plus 5 and an x minus 5. So if I multiply my first fraction by the x plus 5 and the second one by the x minus 5, you can see those denominators now match. So that's going to give us 1x plus 5, 1x plus 5 over our common denominator, x plus 5, x minus 5, plus 3x minus 15. Okay, 3x minus 15 over our common denominator, x plus 5, x minus 5. Okay, common denominator. And now we can keep that common denominator. And I don't want to run into my other problem, so I'm going to go work vertically this time. Keep the common denominator, x plus 5, x minus 5, and combine like terms from the numerators. So in the numerator here I have an x and a 3x that I can combine to make 4x, and then I can also combine the positive 5 and the negative 15, which is going to give me a minus 10 here, negative 10 here. Now that numerator does actually factor. I could factor out a GCF of 2, but because that leaves me a 2x minus 5 and it doesn't reduce with the denominator, the x plus 5 or the x minus 5, it's really okay to leave it in the previous form. So the factoring doesn't help us reduce, which means either one of these is going to be an acceptable answer. So if you left it here, you'd be fine. Or if you wanted to go ahead and factor, even though it doesn't reduce, that would be totally acceptable as well. Either one of those is a perfectly acceptable answer. Okay? All right. Finally, we have one where we have to factor before we can identify what our common denominator is. Anytime we have a denominator that's factorable, that step has to be taken first. So this x squared minus 9 is going to factor into an x plus 3 and an x minus 3, which means my least common denominator is going to have to include one of each of those binomials. So good news for the second fraction, it already has the common denominator. I don't have to multiply the second fraction by anything. But the first fraction only has the x plus 3. It's missing the x minus 3. So we're going to multiply by x minus 3 over x minus 3. That's going to give us x squared minus 3x, x squared minus 3x over the common denominator, x plus 3x minus 3. And then I have a minus, and I'm just going to bring this other fraction down. The 18 over the x plus 3 and x minus 3. Okay, so now I can keep my common denominator, x plus 3, x minus 3, and I can try to combine like terms from my numerators. Now I can't combine any of those terms. Just be careful, this is subtraction, so I want to make sure that subtraction goes with that 18. So I'm looking at an x squared and a minus 3x and a minus 18 to bring down. Now this one's going to actually factor. Let's see, there are factors of negative 18 that make negative 3. They would be negative 6 and 3. And dividing by 1, I can see the top of this fraction is going to become an x, 1x minus 6 and a 1x plus 3. And since the bottom has an x plus 3, we're going to be able to reduce the x plus 3s they have in common. So if we, let's use green, reduce that common factor, then we are left with an x minus 6 on the top and an x minus 3 on the bottom, and that's as far as we can go with that. Okay, I know some of you might be tempted to reduce. You might be tempted to reduce here, but remember all four terms have to have something in common in order to reduce. And all four terms don't have an x, all four terms don't have a 3 in common, so there's nothing we can do to simplify this fraction any further. Okay, so that's going to be our final answer on that one. Alright, let's try this again. Now something a little different is going to happen in number 6. Color mine red. So here, again, we've got a factorable denominator. So factors of, let's see, factors of 9 that are going to make 6 would be 3 and 3, which means this denominator is going to factor into 1x plus 3, 1x plus 3. Sorry, 1x plus 3 and 1x plus 3. Okay, now technically the binomial is repeating within the one denominator, so that would typically mean that we would have to repeat it in our LCD. But if you recognize the top of the fraction is also factorable, sorry, and when you take out the GCF of 7, that means that an x plus 3 cancels out. I wouldn't normally suggest reducing up front, but reducing up front leaves us with a common denominator, and that simplifies this problem greatly. So this won't happen often, but if you can simplify to make common denominators, then that might be a good first step here. So we simplified first on this one. We simplified first because it gave us common denominators. It gave us common denominators. Okay, so it left us x over x plus 3. I didn't mess with that fraction, but it left us 7 over x plus 3. And now this is a very simple problem. I don't have to go about multiplying and then combining like terms and then simplifying again. So we can keep our common denominator, x plus 3. And this is a subtract problem here, so make sure that minus goes with that 7. I can't combine those like terms, so that x and minus 7 come over. And again, this is all we can do here. I can't reduce any x's or anything else, so this is going to be our final simplified answer. Okay? So it won't always work out like that, but if you recognize it, simplifying first, if you recognize that simplifying first can get you a common denominator, then that would be a wise thing to do. Alright, one for you to try if you're feeling good about this. Let's see. Factors of negative 28 that make negative 3 would be negative 7 and positive 4. And so this denominator is going to factor into an x minus 7 and an x plus 4. That means our common denominator is going to have one of each of those binomials. Least common denominator is going to have an x minus 7 and an x plus 4. So the first fraction's good, but the second one is missing the x plus 4. Okay, so we're going to not mess with the first fraction. I'm just going to bring it down. It's not going to change. X minus 7, x plus 4. But the second fraction, we're going to have a 3x plus 12 in the numerator, 3x plus 12, and then our common denominator, x minus 7, x plus 4. Okay, so now we can keep that common denominator, x minus 7 and x plus 4, and I'm not sure why I made that so ridiculously large, okay, and then combine like terms from the numerators. So I can actually combine, excuse me, the 2x and the 3x, which is going to give me 5x. I can also combine the positive 1 and the positive 12 to make a positive 13. And since 5x plus 13 isn't factorable, and I can't do anything else to reduce, this is my simplified answer. Okay? What do we got left? A couple more? Yep, just a couple more for good practice, since that you have plenty of examples to go by. This denominator is factorable. We can take out a GCF of x, which will leave us an x plus 3. And then the second one, we can take out a 4x, and that's going to leave us an x plus 3. Now, this is just like number 6 here. If you notice in this fraction, the 20 and the 4, or you could have recognized the 20, the 4, and the 12, those were all reducible. And if I reduce the 20 and the 12, if I reduce, 4 goes in here once and it goes in here 5 times, then reducing gives me my common denominator, right? They both already have an x and an x plus 3. So if you recognize that, you can save yourself a little bit of work. So these already have common denominators, the x and x plus 3, which means we can go ahead and put the fractions together. So I'm going to keep my common denominator. And in my numerator, I have a 2x to bring down. I can combine, though, the 1 with the 5, which is going to give me 6. And that's going to factor. The GCF of 2 will come out of the top, which will leave me an x plus 3. And on the bottom, if I still have an x and an x plus 3, then I'm going to be able to reduce that common factor. So my final answer is going to be a 2 left on the top and an x left on the bottom. So 2 over x. And that would have taken a little bit more work had we not reduced up front, because we would have had to multiply that first fraction by 4 and then combine the like terms and done a little more reducing. But either way is going to get you the answer. Okay? It's just if you can reduce up front to get the common denominator, again, that's something that you should do because it's going to save you some work. All right, almost there. We got one last one. And again, if you feel good about this, then give it a shot. If not, we'll work it out together. No big deal. Let's see. This is factorable. We've got a GCF of 5, which is going to leave us a 2x plus 1. And then the second denominator, I could take out a 4x squared, and that's going to leave me a 2x plus 1. Now this one's reducible. The second fraction is reducible. I can reduce an x from the top, which will give me a 1 here, and an x from the bottom, which will just leave me a 4 with the 1x there. It doesn't get me a common denominator, but I mean, if it simplifies for you, it's fine. I'm going to leave it alone just because it doesn't help me get a common denominator, and because erasing on my iPad is easy. Okay, so let's just leave it alone for now. Our least common denominator, what is it going to have to include? Well, the smallest number, remember the single terms have to be considered separately from the binomials. Smallest number 5 and 4 go into is 20. And I'm going to have to take the x squared with that, and I'm going to have one of each of those binomials, so I'm going to have a 2x plus 1. So my first fraction, got the 2x plus 1, now I've got to go from 5 to 20x squared. So I'm going to have to multiply by a 4 and an x squared. A 4 and an x squared. And that's going to get me 20x squared in front of a 2x plus 1. Okay? So the second fraction, I've got the 2x plus 1, but I got to go from 4x squared to 20x squared, which means I'm going to have to multiply by 5 over 5. And that's again going to get me to 20x squared in front of a 2x plus 1. So that gives us 4x squared over the common denominator, 20x squared 2x plus 1 minus a 5x over 20x squared and 2x plus 1, again, our common denominator. Make sure the minus goes with that 5x. Now we can keep our common denominator, 20x squared, 2x plus 1, and then try to combine like terms from the numerators. Now these are not like terms, so I'm just going to go ahead and bring down my 4x squared and my minus 5x. Now this is reducible. Hopefully not surprisingly, I have 3 terms in this fraction. Okay, this is a term, and then all of this being multiplied is a single term. So those 3 terms, what do they have in common? They have an x in common. So I can reduce this fraction by dividing out an x. So if I reduce the fraction by dividing out that x, I'm going to have a 4x left, just a minus 5 left, and then a 20x to the first left, and the 2x plus 1. Hopefully that wasn't surprising again, because we could have reduced out an x in the beginning of that one fraction. Since I chose not to, it ended up coming out in the end. Okay, but there it is. 4x minus 5 over 20x times 2x plus 1. Hopefully manageable. You do have some practice problems that you can work on. So if you're feeling good about those, then you're one step closer to getting ready for that quiz. But if you find yourself struggling, as always, I am here to help, so just reach out. All right, guys, take care.